Welcome to aminacademy.com. In questions, how, why, and what. In that, we'll discuss about what are superconductors, how does it work. Superconductors are different from normal conductors such as copper. Unlike regular conductors whose resistance gradually reduces, the superconductor's resistance drops to zero below a fixed temperature, which is the critical temperature. At this temperature, a superconductor can conduct electricity with no resistance, which means no heat, sound, or other forms of energy would be discharged from the material when it reaches the critical temperature. To become superconductors, most materials must be in an incredibly low energy state, that is very cold. Presently, excessive energy must be used in the cooling process, making superconductors uneconomical and inefficient. A study is underway to design compounds that becomes superconductors at higher temperature. Superconductors, what is the definition? Superconductor is defined as a resistance that offers no resistance, substance with no resistance to the electric current when it becomes colder than a critical temperature. Some of the popular example of the superconductors are aluminium, magnesium, diboride, niobium, copper oxide, yttrium, barium, and iron particles. These substances superconduct at temperatures below the critical temperature at some conditions. Now, we will discuss further about what are supercomputers. Superconductors. Superconductors are materials that, when cooled below a critical temperature, exhibit zero electrical resistance and expel magnetic fields. That is a Meissner effect, allowing electricity to flow without energy loss. Zero resistance. This is a graph sees the zero resistance graph of the conductor. Unlike regular conductors like copper, where resistance decreases with temperature, superconductors experiences a sudden drop of zero resistance below a specific temperature, known as the critical temperature. When a superconductor transition, transitions to its superconducting state, it expels any magnetic field that was previously present, causing the magnetic field to be excluded from the material's interior. That means how much electricity pass through, there is no magnetic effect created. Quantum phenomenon. Superconductivity is a quantum mechanical phenomenon where electrons pair up to form a copper pairs, allowing them to move through the material without resistance. Critical temperature. The critical temperature is the temperature below which the material becomes superconducting. Some types of superconductors. There are two main types. Type 1 superconductors, which lose their superconductivity abruptly when a critical magnetic field is reached, and type 2 superconductors, which can maintain superconductivity at higher magnetic fields also. Examples: superconductors include certain metals alloy like niobium and titanium, and a class of copper oxide materials. Applications: superconductors have potential application in energy transmission, magnetic levitation, and medical imaging. Challenges: a major challenge is finding materials that become superconducting at higher temperatures. A current superconductors require very low temperature in near absolute zero to functions according to built-in. Superconductivity. What is superconductivity? Superconductivity complete disappearance in electrical resistance in various solids when they are cooled below that characteristic temperature. This temperature is called the transition temperature, varies from different materials but generally is below 20 Kelvin, nearly about minus 253 degrees Celsius. Use the superconductors in mag, magnetic and magnets is limited. That means the use of superconductors in magnet is limited by the fast that strong magnetic field above a certain critical values depending upon the material cause a superconductor to revert its normal or non-superconducting state, even though the material is kept well below the transition temperature. Suggested uses for superconducting materials include medical magnetic imaging devices, magnetic energy storage system, motors, generators, transformers, computer parts, and very sensitive devices for measuring magnetic fields, voltages, or current. The main advantage of the device made from superconductors are low power dissipation, high speed operation, and high sensitivity. Superconductivity was discovered in 1911 by the Dutch physicist Henk Cameronius. He was awarded the Nobel Prize for Physics in 1913 for his low temperature research. Some, some of the super popular example of superconductors are aluminium, magnesium, diboride, niobium, copper oxide, yttrium, barium, and iron particles. So far, we discussed about what are superconductors. We have done. Please subscribe our YouTube channel.